Hubble on a movable platform lines up the massive telescope as he begins a cold night's work. Having turned the telescope with electric motors to the desired position and coupled the driving clock, he focuses the image and centers the object to be photographed. He attaches a 5 by 7-inch plate holder, just as one would on an ordinary camera. For large telescopes with their great magnification and light-gathering power are used almost entirely as cameras to photograph the wonders of the heavens. When all adjustments have been made, Dr. Hubble signals his assistant to turn out the lights inside the dome, which would fog the sensitive photographic plate. As the lights go out, he pulls the slide, and the huge instrument makes a time exposure of the selected object.
Hello, everybody. This is Scott Roberts with Explore Scientific, and you are watching the FirstLight Chronicles with Scott Roberts and Kent Marts here. Kent, how you doing today? You're all good. You're muted too.
I'm muted and I'm busy. Yes, if you're going to buy a telescope, get the order in because it's crazy what's going on. You and I were talking yesterday. The only time it's ever been busier was during the eclipse, run up to the eclipse, correct?
That's right. 2017, the total eclipse of the sun. It was absolute insanity. We are, that particular event was like, if there was a perfect storm, this is what happened. We had, Amazon had just canceled off 60 or 80 million dollars in eclipse glass sales because of concerns about counterfeit eclipse glasses. And instead of refunding some people's money, they decided that they could not sort out the good ones from the bad ones, so they refunded everybody's money. We were on a short list of recommended suppliers for eclipse glasses with the American Astronomical Society. And, so we were vetted by NASA and them, and we had all of our testing done and everything. And then this tsunami, that's the only thing I can imagine, is the giant wave of business came that we had never experienced before. Maybe giant companies get orders like this, but we got slammed with orders, as did all the rest of the people on that list. I think there were only 10 suppliers or something at that point. Anyways, the current interest in astronomy is really, really high. There are many, many more people getting involved with astronomy for the first time, and people who are already into amateur astronomy have upgraded their gear. It's just really an amazing time for amateur astronomy in general, and all of the entire industry is benefiting from that, of course. But trying to keep up with it is a little tough right now, So you've got, as you well know, Kent, you've been putting in a lot of extra hours, weekends, and all the rest of it, trying to make everything happen as is the rest of our staff. So it's just a super busy time.
We all know, I guess, but we all know the customers own the company, and we have to get their orders out. That's right. And it's to the point that same day shipping's not going to happen. It's just there's too many orders coming in, and we just can't make same day shipping. Yeah. But working nights and weekends, and late into the night and getting here early, everybody's doing it.
Yeah, and pretty much all hands on deck. So
we if we could bring on more people, for the room we would, but we'd have to do it outside in the parking lot because there's no more room in the building, and this just can't happen. We're at maximum capacity right now.
Right. Yeah, and just to give you an idea of our facility, we have 60,000 square feet here. So, it's a little tough at the moment, but we'll get through it. And if you are waiting for product from us, hang in there. We intend to get every order out and to make it before Christmas. So, certainly well before Christmas. Anyhow, I wanted to, for this show, I was hoping to bring Tom Meneghini on live with me for this segment. We'll probably have him on a little bit later, maybe later on this evening. So something's happened. We were practicing a little bit with his setup, and there was a couple of times where his internet froze up, so maybe he has some internet issues. Could also be a time issue. I told him, this time, but he's in California, so so hopefully we synced up like that. But either way, Tom will be on with me a little bit later, and we'll discuss what's going on at Mount Wilson. I'll tell you now that we are planning a live program at Mount Wilson Observatory. It will kick off at 3 p.m. Pacific time, live from the observatory facility itself. And so we plan to go in through the 100-inch telescope and show you, all the amazing features of that telescope. That telescope was the instrument that Edwin Hubble discovered the Cepheid Variable Nebula in the Andromeda Galaxy in 1923. The next year, he published his works on the expanding universe. And, so 1923, 1924, the whole, science of astronomy was turned up on its end. We went from scientists mostly thinking that the Milky Way was all there was to the universe to now all those little spiral nebulae out there are now known to be, island universes in themselves, as they were sometimes called, galaxies. And so it was really a huge breakthrough done with the 100-inch telescope that was built by George Ellery Hale and a team of incredible engineers, opticians, and then the list of astronomers who used the telescopes at Mount Wilson reads like a who's who of astronomy. The 60-inch will be the second scope that we'll take a tour through. So we're going to go 100-inch, then 60-inch. There'll be a tour of the 60. There'll be a lecture from Chris Burns from Carnegie Observatory. And Robert, I think his last name is Anderson. Yes, it is. It's Anderson. And those two will be giving talks, as well as Tom Meneghini himself, who's the executive director of Mount Wilson. They'll give you an intimate tour. They'll answer your questions if you want to ask questions in chat. And then, weather permitting, of course, if it's clear, we plan to have the camera mounted on the 60-inch telescope and take you through planets, Planetary Nebula, some deep sky objects, some galaxies, stuff like that. It should be a lot of fun. I don't know how long the event will go because we're just going to keep going till the questions run out and the astronomers fall over, I guess. So, but it should be just really super cool. And we hope that you make it. Again, that's going to be 3 p.m. Pacific time, December 4th, this Friday. So anyhow.
So what's the cost of that, Scott?
Nothing. It's nothing.
Oh.
This is an outreach program.
Wow.
Global Star Parties. This is part of the Global Star Party series. All of our star parties, all of our events, this show, all the shows we've done are free for the watching. It is Global Star Party in particular is about educational outreach, and we can't host the star parties in person that we would normally do. The Explorer Alliance does host an event called the 60-inch Star Party, where we take people in and we give them tours of all the facilities at Mount Wilson. and then we let people look through the 60-inch telescope, which is really an amazing, really amazing experience. So,
And that was set for July this year, right? Of 2020.
yeah.
So maybe next year.
Maybe next year, maybe next year. So we're hoping, we're hoping. We'll only do it if it's safe. If it's safe, and when we can do it, we plan to take people to the Jet Propulsion Laboratory on a Friday, and then Saturday night, whenever that is, in our calendar will be the 60-inch telescope experience. So that's going to be a lot of fun. We had also planned an experience on the SNO telescope where you could actually see how that historic solar telescope worked, and splitting up the wavelengths of light and all the rest of it. So this is really, really cool. We are broadcasting, by the way, on the Mount Wilson Facebook page. So I wanted to thank Tom for setting that up earlier this afternoon. And so, I love Mount Wilson. I've spent a lot of time up there, and when you visit Mount Wilson, and hopefully some of this comes across in the live tour, but when you visit it, you actually feel the history. It is amazing. Mount Wilson and Yerkes Observatory is where, those two places is where the cradle of astrophysics. It's where it was born. Those two places, and I think maybe there's some argument of where where it started more, but Hale was at Mount Wilson in California for a longer period of time. He eventually, he starts up Caltech Observatory. I mean, the things that George Ellery Hale does, he creates the American Astronomical Society, the Astrophysical Journal, which is still published to this day. Caltech, which of course is an amazing institution in itself, and builds in succession 4 of the world's largest telescopes. All that stuff that he did in a fairly short lifespan is incredible. It'll probably never be repeated, so really, really amazing. But today, Kent, you and I were talking, and you were talking about expectations that beginning amateur astronomers have. I certainly have had, my share of people being surprised that they could not see Hubble telescope-like views through a telescope, and we often, even before a person buys their first telescope, they will ask, just how big will Saturn look, or how close will the moon be, or, can I see those colors, and, there are a few things you can see colors in, but mostly not. So how do you break this to them, Kent, and how do you keep them excited about what's going to happen? Because looking through a telescope is a huge voyage, in itself, and so I think it's important you're talking about the expectations.
The expectations are what the biggest job of that we have is managing those expectations, because people see these beautiful, spectacular pictures on Facebook, and they don't understand what goes into that's hours, maybe a few minutes, but hours or sometimes days worth of camera collecting data and then being merged together in what amounts to an artistic way. It's not like taking your smartphone and going click and taking a picture of your kids out being cute with a duck, right? It's not that photography. You can do some of that with a starting telescope, but they have these expectations of being able to see great detail, great color, and objects that are really big, Saturn and Jupiter. And we've had people who'll call and say, well, Saturn's a little bitty tiny thing. Yes, it's a small telescope. To get that kind of picture, you have to have a lot of telescope, big telescope, and a lot of skills and a dark sight, and you're still not going to see it because the human eye doesn't build up data like a camera can, and you can't stack images in your brain. The places where
if only we could.
If we could see an infrared, the sky would be an astounding place, but
Right.
We can't see an infrared. We can't stack up data over 5 minutes and then go click and let us see it. It would be an astounding place if we could do that. Um, I have a PowerPoint that I show, when we were doing slideshows about, that, and I go progressively smaller and fainter. Most stuff, new slide, that you see in the sky, and it gets smaller and smaller and fainter until you can barely see the words gray. And for most people, the things you see, other than the planets, which have some color and some stars, I see most of it as grays or greens. In my mind, I see a lot of potential green and gray colors. Stars can be blue, but it's the fascination of seeing things, and you try and build that excitement and understanding that that's X number of light years or decades of light years away, and this that integral beauty. Part of what we face is that like 80% of the people in the United States live in a big city or in big cities where you can't see the Milky Way, and that builds a disconnect about what's out there, and they don't see it, and so they have no relationship with the sky. That's part of what we have to face. But a small telescope is not going to give you Hubble performance. Just like when you buy a Barbie car for your kid to drive around the yard, you can't, I guess you could take it to the grocery store to get groceries, but you probably don't. And when you buy a small telescope, it's the same thing. You can't expect $1 million performance out of a small telescope. So there's expectations of what's going to see. And it's hard. It's hard to explain to people that so they understand it. And every once in a while, a few friends on Facebook, they'll post what I see in the eyepiece picture next to what I got after 2 hours of data acquisition. Right. And it's strikingly different, to say the least. How did you handle it, Scott? How do you handle that expectation?
Well, it does. For me, it has a lot to do with explaining what it is that they're going to see, and really talking about the distance of what these objects are. That when you think about even telling somebody that Saturn is 900 million miles away, that kind of just that number seems so big to a lot of people that they just kind of gloss over a little bit, and they're going, wow, 900 million miles away. And when you're telling them that even the smallest, most humble of telescopes, toy telescopes even, can see the rings of Saturn, that seems amazing. Now, I always tell them, look, you're going to see it, and it's only going to be that big in the eyepiece, but you're almost looking 1 billion miles away. So how big do you expect to see something that far away? It is very distant. It helps to describe the proportions of Saturn. Telling them the rings of Saturn, which would stretch from Earth to the Moon. That's how big. That gives them a sense of scale to a degree that they can start to wrap their minds around. When you are looking at stars and nebula, most people today understand that stars have a lifetime. They're born, they go through their sequence of life, and then they expire, only to be remixed back together again in a richer environment, because stars are they're the factories of making the elements of the universe. And so you'll often hear the phrase, we're made of stardust. Well, that's absolutely true. The elements that are in your body were formed inside of stars. Stars are the crucibles. They are the creators of the elements that build up everything. And so
all the metals around us,
all these things. So
your wedding band.
It's exactly. Yeah, our computers, the silicon chips, the everything, and so it's there isn't anything that exists in the universe that wasn't created somehow through the fusion of two lighter atoms making a heavier atom, and the energy that's given off in the formation of that, is where we get, photons and, other forms of energy that are out in the universe. But it's, for a lot of people, it's not really top of mind. For a lot of people, they think that everything's separate, nothing touches, or, in a way, nothing's really quite that related. We navigate our world thinking that everything is separate, and that there is no relationship. That is something that it's a misnomer or an illusion that we have, as we live our daily lives. Very few people walk around thinking how intertwined, interrelated, hardwired they are to the whole universe. And that we're flying through space, and that we're all part of this cosmos. Amateur astronomers think about that probably more often, I would say, as a group of people. Cosmologists probably are almost completely occupied with that knowledge, so that's but it is fun to be an amateur astronomer and to be able to look out through your window of the glass on your scope and to see across thousands or millions of light years into space, and to see some of these processes happen, in different stages. So you can see things like where stars are forming, like in the Orion Nebula. You can see stars that have gone through the throes of death, in Planetary Nebula and supernova remnants. You can see these island universes of stars. And then you can see the transient phenomena in our own solar system with comets, rotations of the planet, the orbits of the planets. A really great example of that's going to be on December 21st. We're going to see Jupiter and Saturn come within 6 arc minutes of each other in the sky. And that hasn't been, they haven't been that close together in the sky for over 300 years. And so that's going to be a really, really cool event. You're not going to want to miss that. That's December 21st. We're going to have a special online live event for that. I think it's talking people through the distances, the scale of things, and the fact that that you are, just take Saturn for example. You're 900 million miles away from that planet, yet you're still seeing detail. That is incredible. Okay. If you think about just seeing a license plate with the naked eye at more than a mile away, you're not going to be able to make out numbers or any features whatsoever, But a telescope can do that, and it can see fine. An example is just to take someone out with their telescope and show them, a small feature on a car or something like that at half a mile away. And now imagine what it would do if you pointed up at the moon, and all the detail that you're going to see.
The distances are
Saturn again.
Yeah, the distance is something I talk about, and I use the moon as an example. You don't really comprehend how far away the moon is, but the moon is, I may have talked about this on another broadcast, the moon is, 338 million miles on average away. That equates to 1.2 and a half light seconds. So the moon is a light second and a half away. So from the time the moonlight strikes the moon and it lands on your eye is a second, 1.2, 1.3 seconds. And which, okay, that's not that big of a deal, except it took the astronauts 4 days to travel there. Once they left Earth orbit to get to the moon, and 4 days to get back. Well, to put that distance into perspective, if you got on a 747 that had an unlimited fuel supply, and you're out in space, so once you get going, you just go. But it goes to the moon at the speed that a 747 travels, you would be just over halfway there when you passed the Apollo astronauts coming back to Earth, because it would take you 16 days to get there. And so just to get to the moon, it took them 4 days to get there. On a 747, it's still 16 days away. And it just, which is effectively what? A 747 could fly around the Earth in what, 24 hours? Not even 24 hours. What would it take, Scott? 36 hours for a 747 to travel orbit to go around the Earth? Something along that line?
Probably less than that.
Certainly depends on, along the equator.
Around the world, but, you stop, you get fuel, that kind of thing. I don't know, maybe there are planes that can go around the Earth without refueling.
But the whole point is, it's a long ways off, and it's the closest thing.
It's a long ways off. And if you think that light, the distance that light can travel in 1 second, which is like something like 186,000 miles in 1 second. And now you add up all the seconds just in one light year, okay? 1 year of seconds, multiplied by 186,000. That comes out to be a pretty big number all by itself,
And we haven't even got out of our front yard yet.
Right. Yeah. So in 1 year, you've already traveled, if you're traveling along with the speed of light, you've gone 5.9 trillion miles. Okay.
And you've got 3 more years to go before you get to the closest star. Yeah. It's just unfathomable distances.
Right.
So anyway, and I try and use those numbers and talk about when you can look up and see Andromeda Galaxy and realize that it's the furthest thing away you can see with your eye. And the fact that those photons left Andromeda 2 million years ago.
Yeah, the original photons, not copies.
Yeah, the original photons.
Right.
And those photons have been traveling unchanged for 2.5 million years. For them to look up their entire destiny, this entire time, has been for you to look up at that very specific moment, and those photons go into your eye and get converted into nerve energy. You now have absorbed energy that is provably over 2 million years old. A single photon and all of its photon brothers and sisters are now inside your body, generating an image that your brain sees. And if that doesn't make you feel small when you're out there looking up at it, I don't know. Yeah, and some people don't care, and other people go, wow, I never really thought about something like that. So I try to relate the scale of those things. And, but I think it's critical just to get out there and look at stuff, which leads me into, I started thinking, it's December the 1st. Let's talk about what December is going to offer. And we know December is going to offer, a couple of really big things. The biggest one is the conjunction of Saturn and Jupiter on
a huge monster event right there.
Right.
That's true.
And if you're going to try and photograph it or look at it, you need to get out and start doing, using your telescope. Now, so many times we'll have people come in, or they'll buy online 4 or 5 days before some big event happens, and they're toast because they don't know how to operate. That's like saying,
you start asking the questions. Have you ever done astrophotography before? No. But I got a camera I can attach to the back of it.
I've got a Nikon, or Canon. I can do that. Yeah, you can. Just like if you'd never seen a car before, and seen a car, and you'd seen a car maybe drive down the road.
Yeah.
But you've never driven one, and you're going to decide you're going to drive to Miami on Tuesday.
Yeah, and you're going to buy a new car to do that.
And drive it with never having been in a car, don't know how to turn the key, don't know the gas pedal, don't know where Miami is, and you're going to drive to Miami.
Now, Kent, what I will tell you is that over all the years I've been selling telescopes, I have run into people totally green, never used a telescope before, bought it a week before something was supposed to go down, and came back, and this is back during film days even, and
which made it harder.
Beautiful images of the Orion Nebula and stuff, and I'm like, holy smokes, you took that? And they're going, yeah, I hope they're good. It's something like that, and you're just like stunned.
Yeah.
I've been very jealous of those people.
Yeah.
Some people just have a natural
Yeah.
knack for it. For most
That's
of us,
true.
it's a very long learned process. It's shorter now, way shorter now because of electronic imaging. You get to see your result immediately. You can tell
Instant
if you're out
feedback.
of focus. You can tell if the object isn't centered. You can tell all these things.
Right.
But to get the really beautiful, magazine level images, that takes a while.
Right. So what else is going on? Well, we had a full moon, just over a full moon. We missed having a full moon in December by a couple of hours. So otherwise, the first full moon in December on the 30th would have been a so-called blue moon, which most people means 2 full moons in a month. So
Right.
there's not a lot going on. So it's in the evenings, the moon's
What
going to
about
come
the
up.
total eclipse in Chile and
Right.
Argentina?
There's a total eclipse coming up in Chile and Argentina. So if you want to jump on an airplane and drive down there and hope they let you into the country, you can try it.
Or maybe you're watching from Chile and Argentina right now,
Yeah.
and you can take off and go check it out.
Right. So we know we have friends in
We
Chile
do.
and Argentina that are going to be taking off and checking out the total eclipse. So, the nights of December 13 and 14 are the Geminid meteor shower. Not a big shower, but because the moon is going to be well past the full moon and moving back towards a new moon, it's going to be really a good time. And meteor showers tend to be best in the morning hours, from 1 or 2 o'clock until sunrise. So, but going out in the evening after it gets dark and looking up, you're better off if you can get outside city lights with meteors, because they tend to be faint, and if you're under light polluted skies, only the biggest, baddest ones are the ones you're going to see.
Yeah.
And one every hour is not really that exciting and hard to keep kids' attention. But 20 or 30 an hour, gives you some oomph. And I haven't looked up what the predictions are, but the Geminids can be a nice little shower if you catch it at the right time. The next day is the solar eclipse on the 14th. And the path of totality is in deep South America. December 21st is the winter solstice. It's when fall ends and winter begins. For our northern hemisphere listeners, and for our southern hemisphere listeners, summer is starting, and so or what would it be? Yeah, spring is starting. So spring is springing. So on the nights of December,
You said spring is spring?
it'd be summer is summering. Spring is springing. Springing. Fall is falling, and spring is springing. But they would be going into summer, because we're going into winter. December 21, 22, the same night as the Jupiter-Saturn conjunction, there's the Ursa meteor shower. Again, it's a minor shower, not much, but hey, something to do. If you got good clear weather, get out and go see how many meteors you can see. And then causing problems is, you got the full moon on December 30th, always, great to see, but it creates light pollution for those of us.
Yeah.
So anyway,
You're talking about the moon?
Yeah, the moon causes light pollution.
No, you're kind of a deep sky visual guy, right?
Yeah, but
deep sky visual guys don't like a big full moon.
Yeah, that's true. Or astrophotographers don't like it. Now, we had a guy in the store this morning. He had bought a telescope yesterday. Yeah. He was in, and he came back just talking. He was like, about blinded myself last night, and he discovered that a 10-inch Dobsonian telescope looking at the full moon pours a whole lot of light into your eyeball, to the point that
blind you, but it will low.
It certainly it'll leave a white. It's like if you look at a bright light bulb, or a camera flash goes off, and you can see it. It will do that.
A latent image after that. That's
right.
True.
And so I was like, pretty easy to deal with. Take a piece of cardboard, put it over the front of your telescope, cut 3 or 4 holes in it, just round holes, stick it up and put it in front of your telescope, and you'll cut the light down by 60 or 70 or 80%. And suddenly the full moon is not nearly as bright,
Yeah,
but
and sometimes the image looks sharper too because
correct.
maybe you don't have the seeing conditions for the big aperture of your telescope, but you might have it for a smaller aperture,
Right,
So
right.
that's the advantage of owning a big telescope is you can do that.
And if you have a Newtonian or if you have a regular refractor, you just cut a smaller hole in the middle. But what do
Yeah,
you do if you have a big Newtonian that has that secondary in the middle? Well, you've got to cut a hole here and a hole here and a hole here and a hole here, and you can use 4 holes. And people
or
go,
one.
or one hole, but
Yeah,
people go, but it's off to the side and there's 4 holes. Once you have 4 images, no, it all gets mashed in together into one small thing that goes into your eye.
yeah,
And some people like hard to get their minds wrapped around that you can cut 4 holes in a piece of cardboard and put it in front of your lens or a manila envelope or whatever, put it in front of the telescope, but yet you only still see one image. They just
right.
like binoculars, sort of. So anyway,
Until you start to get actually when you cut multiple holes and you start to get a star image, you'll actually see multiple stars, and they'll start to come together as they form one star at focus. So that's
at
when you're out.
focus,
That's when you're out of focus. You will see multiple images
right,
come through.
right.
That's true.
So
Uh,
anyway, expectations.
Expectations. That's right. So we got some comments here, and I'd like to recognize some of the people on the show today. We got Stefan Del Pra, who's been following us regularly. Andrew Corkill, of course. Prize winner Andrew Corkill has won so much. That's great. And he has one of our ED 152s. I wanted to give him a little bit of a shout out because he just finished an observing program with the Astronomical League. So that's awesome.
Which one, Scott?
It was, I think, the double star one that he did. Here he is. Yeah, Scott, I just finished the Astronomical League double star observing program and used the Explore Scientific 152 ED APO for most of all the double stars, which is very cool. Mike Wiesner says he's watching from Arizona. Jeff Wise says he's watching from Northern California. Bergman Scooter says hello. We've got, who else? David Swanson. Greetings from San Diego. Yeah.
So all you people, hey, like, share, hit the subscribe button. That stuff everybody says.
Oh, yeah. It helps
we want
support us. That's true.
we want to grow this community. When you get on live, share immediately that you're getting on with all your friends and help us boost the reach of this program and help spread the word.
That's true.
Yeah.
Michael Whitaker says hello to everybody. Pekka says hello from Stockholm, Sweden. Nice to be here again.
Hey, Scott, you realize that we need to take a trip to see all these people, don't you?
Okay. One day.
One day we just need to leave and go to Stockholm and Argentina and Australia and visit all of our new friends, because that would just be spectacular.
That's right. Maybe we'll call a big star party and everybody will meet converge somewhere. David Swanson is watching from the Mount Wilson Observatory Facebook page. So we've been broadcasting on that page today. Stefan says, love how he has the smoking pipe. That is so cool. He's talking about Edwin Hubble, That's right.
Let me tell you about what that causes, because I'm a part of an organization that has a small little refractor. It's a it's a 24-inch f/18, which means it's 2 feet diameter and 36 feet long, and it's
100,000 pounds, right?
Yeah, 50,000 pounds with a mount and everything. And we had taken it apart, and one of the guys and I set about cleaning it, and the finder scope was absolutely filthy, and you could smell it with cigarette smoke. You could smell the cigarette smoke on the bottom half of the tube. The top of the tube, which was up in the air where the primary mirror or lens is, was astoundingly clean. But the bottom part of that telescope, they all
in their pipes, huh?
They were all just smoking at the eyepiece, and now if you do that at a star party, you're gonna get yelled at by people, because that smoke likes to stick to optics. and
Well,
creates.
you might get yelled at everywhere these days.
Anymore. Right. But it was interesting. I had the same thing on maybe smoking a pipe at the eyepiece. Wow.
That's cool. Who else do we have here? We have James T. Mott from Long Island. We've got Royce Murphy from Gloucester, UK. We've got Louise Helmers from Covina, California. We've got LL from Cape Cod. David Samard is watching. Jim Norwood. He says if the demand holds up, you may be able to get out of that old RV into a more modern one, Scott. No way. I love my 1968 Airstream. Let's see.
We need to do a tour of that one day, Scott, for the FirstLight Chronicles.
I will.
Let people see that.
Louise says she has an 8-inch Meade reflector. That's awesome. Clear Light 58. Funny, when I was growing up, that was the coolest telescope on the planet. Now, as cool as it is so small by comparison. He's talking about the 100-inch at Mount Wilson. So some of the new ones out there, but it was it was the start. That's right.
The thing about a lot of these big modern telescopes is they're not optical telescopes. They're really cameras. They're telescopes, but they're cameras, and they work in wavelengths of light, and you can't put an eyepiece on them. And so I think those telescopes that you can put eyepieces on have a certain attraction to my heart, because that's a human connection with a telescope. Mm-hmm. It's really just a connection to a computer screen. I'm not knocking them. They do great work, amazing science instruments. But there is the romance of walking up to a really big telescope and putting your eyeball to a good eyepiece and having all those photons stream down into your eye.
That's true. Visual views through a telescope, especially like Mount Wilson's 60. Gosh, if you can look through that 60-inch telescope, the views I've had of Mars, Saturn, seeing globular star clusters in M31, seeing color in Planetary Nebula, it's jaw-dropping. It is really, really cool. Of course, the 100-inch was mostly used for photography and during its most productive era. Today, it has a big eyepiece on it. It uses actually an Explore Scientific ED-127 tube assembly, looking at a diagonal through another diagonal that looks down on the 100-inch mirror. And that's how you look through the 100-inch telescope. You use an Explore Scientific telescope to do it with, which is totally cool.
You look at the telescope with a telescope.
With the telescope.
That's awesome.
Yep.
That's awesome. So I've got to use the at McDonald Observatory, the Struve telescope.
Oh, it's a big telescope.
It's an 82-inch reflector.
Right. Yeah.
And that night we observed back in 2007 or 6 or whatever it was. We saw. I need to dig these pictures up and do a presentation about it. I've never really talked about it, very limited publicly. But we saw what would be Ursa, now the 12th planet, and the 10 people on the trip and the two professional astronomers were the only people who've ever seen it, and gonna see it until, I don't know, 300 years from now, until it comes back and gets close. But so the end of the evening, we stayed all night. We were the only people that astronomers had said that actually stayed all night. And they said, "What do you want to look at?" And I said, "Well, let's look at M42." And somebody said, "Well, why look at that?" And I said, "Okay, fix something else." They said, "Well, yeah, okay." So we swung to it, and I won't repeat the declaration that the person at the eyepiece said, but the first word was holy. And the field of view was so narrow that you couldn't see all the stars of the trapezium. And you could see oranges and greens and blues and yellows and festooning and things that looked like
big aperture will do for you.
That's the pillars of creation, little things. You could see little planetismals. And other than the coolness of seeing a dwarf planet no one ever seen before, that was the thing that everybody talks about. Ran into some of the guys when we went up to Yerkes, 3 years ago now, to the Yerkes Starlight Festival.
Yep.
The thing they talked about was looking at M42 at that kind of narrow field of view was truly astounding. So that's where my love of eyepieces comes from. Telescopes with eyeballs.
Yep. Jacqueline Gardner asked, can I recommend the live tour of Mount Wilson to my students as a sort of virtual field trip, or is it geared more towards adults? Jacqueline, it's geared towards everybody. By all means, have your kids watch. It's for a lot of people, they'll never get the chance to visit Mount Wilson. And this is a chance to see it live, to actually interact with the astronomers who work there, and to see some of the rarely seen features of that telescope. Scott Hahn is watching. Louise Helmers, thank you for doing these. Thank you for watching, Louise. Tim Thompson, love Mount Wilson. Yes, he does. Tim Thompson is a great astronomer that works there. Rich Evers, Temples of Science. Yes, they are. In fact, you go into the 60-inch or the 100-inch or Palomar's 200-inch telescope, or the Yerkes 40, any of those telescopes, including many others. But there is a feeling of like you're on hallowed ground. This sacred feeling, that which is why these old observatories are worth preserving and keeping functioning. Because they are such huge inspirations to people. There was conversation by several of the people on the chat about Arecibo. Now, at its end of life. And so, it is sad that it's started to fall apart, but, thank goodness that we had it for the 50 some odd years that we did. It really helped advance the science of astronomy, and probably created more questions than we had answers.
It is sad that we weren't. I don't want to think that it came down to a lack of maintenance and planning, but certainly seems that way. From that structural engineering, the state it's in, they should have been able to predict it. You think. But it just shows how tight dollars are that they weren't able to stave it off and prevent it from happening. But let's face it, it isn't a hurricane zone. So after how many hurricanes have hit it, it finally, met its maker, so to speak.
Yeah. Rich Evers said if there were only folks with billions of dollars hoarding it away instead of investing in awesome tools for humanity. Well, there's lots of things to invest your money in, and some of the billionaires are actually doing some amazing things for humanity, I think. That may not be true with all of them, but anyhow, Tim Thompson responds. He says, money, extremely expensive, and the Chinese have the 500-meter fast now. That's the 500-meter aperture radio telescope that's out there. That is an amazing instrument. Clearlight 58 says, I had to explain this to a friend who was going to rent a telescope for the Jupiter-Saturn meetup. There's a lot of misconception of how small a planet really is in the eyepieces compared to, say, the Orion Nebula. That's true. That's what they need us for, as amateur astronomers, to interpret some of this for people who are just getting onboarded. Michael Whitaker, having included a camera to this hobby has opened up another universe, as well as what you can see. Just looking at a one-shot image on the preview screen blows me away every time. Aaron Thompson said that was a good RASC video on periodic table matter production from different star types recently. Oh, very cool. I'll have to look for that. Pekka says, a small thought, when you are observing visual, do you think void of space 2D or 3D? Do you think about the void of space in 2D or 3D? What's it like?
I'm thinking about the 3D.
You do in 3D?
Yeah. I like to look at like Orion Nebula or the Ring Nebula and think about the dimensionality of it. I think that gives a more personal feeling to it, maybe. The moon is really good for 3D because the shadows give us a true understanding of its depth and height, and you can see the curvature of it because you can understand that that's on the side of it. That's a crater, but we're seeing it at this angle, not all the way around at this angle. And I think those things give it. I really try and think of space as, this big block of jello that we're stuck in the middle of. I found it interesting that the news came out that we're 2,000 light years closer to the center of the galaxy than people thought, and it's massively closer. No, we're still like, I don't know what the distance is, but 2,000 light years does not matter to us.
Right.
It makes great headlines, but still, the scheme of things, it's. Yeah. But anything to make people think about astronomy. I like that aspect of it.
Right. Apparently we made a mistake when we were talking about these distances. We goofed by a factor of 1,000 at one point. We're just enthusiastic.
On which one?
I'm not sure. It says, Kent, you were off by a factor of 1,000. Now, I do the same thing, and this happens. So the moon is only 250,000 miles away, not hundreds of millions of miles.
I didn't say hundreds of millions, did I? I may have said it's 340. 340,000. I may have said 340 million. That's entirely possible. I said 340 million miles.
I have made that mistake myself. Kent does know the distance.
I've walked it.
Yeah, that's
uphill
right.
both ways. Uphill both ways in winter.
That's right. Clear light 58. Also, if you're going to near the speed of light, if you went to the nearest star, by the time you turned around and went back to Earth, everyone you knew would be gone for a very long time.
Hey, there's Tom.
Yes, I got the memo late. Hey,
Tom, I'm sorry. I knew that I blew it.
I was out in the back. I was out in the back 40 doing chainsaw surgery.
I go, did I tell Tom Pacific time or Central time or so?
Oh, anytime. It's good.
I'm glad
here.
You're on with us. We talking about expectations by people starting in astronomy and what they'll see in an amateur telescope versus, and we've also talked about what you can see through things like the 60-inch telescope, for example, at Mount Wilson, and trying to give them a sense of that. But it's great to have you on with us. I see the puppy back there, so we're glad to have you on, Tom.
Is that a border collie?
Yes.
Yeah. Those are smart dogs.
Here you go.
Look at that! Oh, look at that face.
Smarter than me.
Right. So I was talking a little bit about the event itself. Tom has created the schedule for the event. How do you see it going? I've told him we'll log on, for the early log on at about 3 p.m. Pacific time, okay, which will make it 5 p.m. Central and 6 p.m. Eastern, okay. And then probably about 30 minutes later, we would have talking heads at that point. But the way I described it is we would go through the 100-inch and then the 60-inch and then live viewing through the 60-inch. What would be the highlights? How would you describe that? And maybe you could talk about Chris Burns a little bit.
Well, I'm hoping they're all highlights, but I think they're all informative and entertaining in their own way. If I can get to places I want to in the 100-inch, it will be good. It's going to be a function of Wi-Fi robustness in the dome and or Cat5 cable length. So and I'm just going to have to go in and strategize how I can hook up quickly to get to some of these places that nobody gets to see. And I think that's very entertaining. I'd like to go to the Coudet.
Oh yeah.
For the spectrograph for the 100-inch. Nobody goes in there. It's like once a year someone goes in there. In fact, I have to make sure the lights work.
It's fun watching your dog play with its own shadow. I'm sorry, but I have to. Your dog is over there playing with his shadow, and
she chases everything. Yes, shadows, everything, anything.
That's
anything
awesome.
She's after.
I've got another meeting. Oh, that's impressive. That she's beautiful for 12. I've got a meeting getting ready to start for the other project we're working on, Scott. So I'm gonna go ahead and drop off.
Okay, that's great.
Tom, I look forward to getting the tour and the insider's view of places nobody sees. That's always awesome to see. So thank you for offering us all that opportunity.
Well, thank you for giving me the opportunity. Thanks again.
All right, you guys have fun. Bye.
Thanks, Ken. Take care. Okay. So I'm excited about that because I've been in the 100-inch a few times. Spent more time in the 60-inch telescope. I was trying to describe what it's like to actually look through that big 5-foot mirror. So
right.
I got to see during that great opposition of Mars when it was at its closest in 60,000 years. I saw, Mount Wilson has often very, very good seeing conditions. I mean, the stability of the air can be remarkable. And I saw terrain on Mars. You could see cloud cover, and certainly the ice caps were, very clearly defined. Saturn is spectacular in the eyepiece. You can see kind of that olivine color on the planet itself, and all that structure in the rings. You can see the kind of the spokes or that kind of shadowing in the rings. It's not to be missed. Jupiter and seeing its moons as spheres, not like stars, in the eyepiece, but little spheres. That's beautiful. I talked about looking at the Andromeda Galaxy and actually seeing globular star clusters in Andromeda visually, color in Planetary Nebula. What do you think that the lineup of objects would be like? You were telling me a little bit about it earlier.
We did a group for a community college here a few weeks ago, and we were able to get to Jupiter and Saturn. They were twilight objects, but we could still see them. Contrast was a little low, and I don't know that we can get to them for this session, but we're going to try. The other would be a Planetary Nebula. We did the Blue Snowball. We could do the Ring Nebula. I think the Blue Snowball is better.
Yeah.
We did M15. We did NGC 7331, which is a edge-on spiral. We did a few double stars, and we did about 5 objects altogether. We did Mars, of course, and it was a night of very good seeing. I hope we have something comparable on Friday. It looks weather-wise like it's very similar conditions to what we had. Totally clear. It's very stable. It's cool, which means the ground stays cool, which means minimal thermal effects early in the evening. So hoping it all comes together and we have a good session. So I'm looking forward to it.
Oh, I am too. And I'm so grateful that you've been able to put all this stuff together so quickly. We didn't take a long time to do it, but you know what you're doing.
You put it together. I don't know what I'm doing.
No, it's
I'm
all
just saying,
good.
Scott, help,
It's all good. It's all
No,
good.
so we'll get through it. We did it once, so we can do it again. We know we have the technical capability, so that's been established. So it's a matter of how smoothly we do it now.
Yeah. Now tell us a little bit about the camera that you're going to attach to the 60 inch. What is that?
This is an Attic CMOS camera, full color. It's chilled. It's has its own proprietary software, which is kind of strange if you've used any of the other shared softwares. This is just strictly for Attic cameras, and it does a good job. The controls are a little well, for me, strange because I'm used to other software. But Chris Burns he's got it at home right now. He's practicing with it on his 8-inch, so he can play tunes on it right now. So
he's
I'm going to let
practicing
him
on an
take
8-inch to put it on the
that.
60 inch.
Right.
I guess it's
Same,
just a
same,
matter of
it's same
scale.
technology.
Yeah. Mm. And the 60 inch too, I mean, it's got its own rich history. I mean, it was the mirror, from what I understand, they had George Ellery Hale's father made it possible for him to get that mirror, right? Was it a
I
gift?
think it was a, I think, well, from what I hear, if I remember correctly, it was a birthday present for George from his father. I think it cost his dad $10,000 at the time to have this mirror blank cast in France, Saint-Gobain Glassworks in France, who were the only glass producer in the world who could do that in much in one melt or one pour.
Yeah.
And it came over and it sat through till 1904, 05, or a little bit later, when Andrew Carnegie was talked into funding the 60-inch scope, the dome, and so forth. And the Mount Wilson Observatory under Carnegie was formed at that time. George Ritchie, who was an engineer, optician, astronomer, just a Renaissance man. He could do anything, I swear. And he designed and ground the optics. They're very good optics. They're excellent. Still, they're diffraction limited optics, which you don't find much anymore.
Right.
So the sights I think are wonderful when conditions are right. It's very good. If they're not so good, a big mirror gives you amplified defects as well as good stuff when it's excellent.
Right. That's true. That's true. And I guess some of the more famous astronomers have used it. Harlow Shapley, discovering that the sun was not in the center of the Milky Way, right?
Right.
I'm sure that Hubble, well, I know Hubble used it because when you go through the tour, and maybe we can show this in the video. I don't know if you can, but the lockers are right there beside the steps. And Hubble's locker is there. And this is not like something you guys mocked up. This is Hubble's locker, okay, is really there, along with a slew of other iconic astronomers just right there. Just to stand next to it and to be in the presence of those lockers is really, I don't know, for me as a total telescope nerd, okay, awesomeness. I love that. And then you ascend the stairs and you go up and often you guys would be running some sort of stargazing event for an astronomy club, which you do often or have done often. And then you see this incredible, beautiful, amazing 60-inch telescope that is, I guess, the prototype of all the modern telescopes made today.
Very true.
Right? And
that's what it is. It's the progenitor of all modern telescopes. And what he designed into it was 3 types of telescope. He had the Newtonian focus, which is the wide field at the top. It has a Cassegrain configuration, which we'll be using, which is f16. And then it has the spectrographic focus, f30 Coudet. So by changing the top section of the telescope which has the proper mirror and distances. He could do 3 types of observing in one night if need be, by changing
Brilliant.
the
In one night.
stage.
In one night, he could
In one night.
Wow. You'd have to be really good at working with
You
the
would have to
telescope.
really be good.
Yes, you would. Yes, you would.
I've done it. I wasn't that good.
Now, is the telescope ever still used at Newtonian focus? Have you guys tried?
No, we have the Newtonian cage, and I'm trying to think of a purpose if we can find or get funding for, camera with a big enough chip on it to handle an F5 type of field, which I really don't know how much it really encompasses right now. But we could do that. There's a practical application for it. We could do that, or even prime focus, and just do away with the diagonal mirror.
Right.
So these are possibilities, but it's a function of funding.
Right, money. Well, earlier in our program here, people brought up about Arecibo, meeting its demise and
Right.
ending its life, and we almost lost Mount Wilson to fire. And so
Right.
I was sitting here with thousands of other people watching the live cameras from Mount Wilson and watching the fires get closer and closer. And then there was that one scene where you could see the flames leaping up behind the monastery where the astronomers would sleep. Where I've stayed there several times, and lots of my friends have stayed there. And it was like, horrific to see this, and but I don't know the full story of how Mount Wilson was saved this time. I know that the firemen that were there played a huge role in that, and I know that you gave them a special treat at after the fire.
Mm-hmm.
But what do you think? What did these guys do to save the facility?
Everything, you name it. They cleared spaces around buildings, got rid of underbrush. And I should tell you that Mount Wilson is on a sheer precipice on 3 sides. It is steep all the way around. If you should roll off the mountain, you're going to roll for 1,000 feet down easily. You're going to go down fast and far, and it's dangerous work even around there. That's what made it so difficult, was the terrain. It's very, very steep, and when fire comes up the side of a cliff, it comes up really quickly because it's very steep, and if it has fuel, it'll just rush upwards, and that's what happened around the monastery. That's one of the steepest parts around the mountain. There were 300 firefighters up there at any given time, at least in the area. We had completed 2 or 3 water projects or fire infrastructure projects. 2 years ago, we refurbished, renewed, rebuilt our 500,000 gallon in-ground tank that we use for fire suppression. So it was filled with 530,000 gallons of water, which when they came up, they had no idea that they had that much water on the mountain. So they were able to hook into there. They were able to hook in everywhere on there. We have like 19 fire stations around there for hookup. So they were able to do that, hook their pumper trucks up to it to get pressure. So they were able to have, and I think they used about 270,000 gallons of that. So, and then in 2 months before that, we completed a replacement of our fire hydrants on the outer part near we call it this Cosmic Cafe. It's a big parking lot, and that's where the helicopters land to get refilled, either with fire retardant or water. And so we had renewed these 2, done all the piping. So these hydrants were ready to go. They hooked right up to them. They were supplied with about 210,000 gallon tank there. So they were able to have plenty of water to do this, and I think that was a big factor in putting this fire down, because it hit us successively from three sides. It started from the east, it went around to the south. We thought we were done, and then it came around the north side and tried to get us each time. So it was a long fight, and I was just tired watching it. But those guys really, really, really worked hard, and it was a pleasure to treat them to nights on the scope when it wasn't too smoky, or too much ash falling. So they were pleased. I still owe some of them a night on the scope.
Oh, sure.
They went off to fight other fires. I think they're done by now, but I owe them, and some of them are local here that they can come back here, and I can certainly entertain them with that.
Yeah, the firefighters are real heroes. I mean, preserving things like Mount Wilson, people's homes, people's lives. I mean, it's just an incredible situation. We had so many fires this year. I don't know if it was a record for California, but it must have been a near record, I would imagine.
I think the acreage burned was a record in terms of not only numbers of fires, but of the extent that they covered, or the areas burned. It was I don't have the number in front of me, but it was a lot. In other states,
millions of acres
were having the same fate.
Yeah. So and Lick Observatory it was almost done too. I remember seeing a video of that, and going, that would have really ruined my year, Tom, to lose Mount Wilson and Lick Observatory.
Mine too.
Especially for you. Especially for you. You've been at Mount Wilson for how many years now?
About 19 years now.
Quite a while. It's quite a while. And what attracted you to hanging out there? Fate,
fortune, good fortune. Right. I've been a lifelong amateur astronomer, and I had been working overseas for a fishing group out of Guam, and I said, well, it's time to come back to the States, and I came here and looked around, and I said, well, it's time to dust off my scope and start astronomy again. And I looked at my scope, and it needed more than dusting, so I went out and got a scope. But I brought it up to Mount Wilson for a star party that they invited amateurs to come to. And you remember Dave Jarasevich?
Oh, yes.
So he invited me to start operating the 16-inch LX200 that you're responsible for getting up there. And I started on that, and he kept asking me if I'd like to run different scopes, and I of course said yes. And I said yes successively, up to the point where they said, would you like to be the director? And I said yes again.
And the answer was yes.
6 years ago.
That's awesome. That is awesome. What a dream come true, really, for anyone that to go up the ranks from amateur astronomer to actually being the executive director of a historic place like Mount Wilson. I think in particular, knowing all the history and just the interaction that Mount Wilson has also with the general public, the interaction that you have with the amateur astronomers in the area and stuff, it is really it's beautiful, it's inspiring, and it is especially when you think of how many times Mount Wilson almost met its demise to fires, almost met its demise because of lack of funding, almost met its demise, but it still continues on. It's mostly run by volunteer
That's
help.
Right, yes.
And so, and the 100-inch and 60-inch telescopes look beautiful. You guys do an amazing job in taking care of them. You maintain those mirrors. You have updates have happened in electronics, and you guys are looking forward to making the instruments. Not only they've been used visually a lot, but one of these, this run that you'll do with the ATIC camera on there is to kind of show astrophotographers that, hey, you can use these instruments also photographically. do you think that there'll come a time where people will be able to rent photographic time remotely with these telescopes? Is that a thought?
It's a thought, and in the sense that, like they have in Chile and in Australia, where you actually remotely operate or move the telescope to your objects.
Yeah.
I don't think that's going to be possible with these old telescopes. I think there's going to have to be an operator there,
Oh, sure.
pointing and intermediating. But as far as acquiring images, I think that's very possible.
Very possible.
That's what I want to do. And we're also, as I mentioned to you, Scott, earlier, that we're having a guiding loop on the 100-inch scope. We'll be testing that as soon as we get a little bit past this COVID situation we're in right now. So
you'll have
we're
a
gonna be
guide
testing that
scope on there, or you'll use an off-axis guider, or how do you?
We'll use an off-axis guider. We have a 10-inch mead on the side of it, and we have PD2 software, and it finds things. It likes to guide them. We have to close the loop to the control system that we put in to see that it actually, does try to follow the star, and if it's responsive enough. So this is still much in the testing phase. We hope to do longer exposure photography and at least guide out the periodic error in that system to allow that.
Right. And you told me that the 60-inch has a remarkably good drive on it, and that you're doing some unguided work with it, correct?
Yes, which is, with stacking and, lucky seeing and so forth, if we happen to catch a worm period on the gear, well, the software throws it away. So it gives it opportunities to get a lot of exposure. It gets a lot of light, so we can take fairly short exposures too.
Right. Yeah. So, we've had several astrophotographers on our shows, and a lot of these people are doing photography from the city using narrowband filters. So while the days of really dark skies in the visible range, anyways, the infrared sky at Mount Wilson is very dark, from what I understand, one of the darkest infrared skies in the world. But in the visual range, using a camera on the 60-inch and the 100-inch with narrowband filters might prove to be very, very interesting. So we have a guy, his name's Chuck Ayub, that comes on our show from time to time. Another guy named Jason Gonzell. Both of these guys do narrowband imaging. Chuck lives 6 blocks away from downtown Detroit. Okay. And if I showed you some of his images, and maybe you've seen them on Facebook or some of the other social media, you would be blown away. I mean, it's just, you would think this guy was in the darkest skies in North America taking these images. So the technology has come a long ways, and so that it's exciting to me that maybe Mount Wilson will get some new life breathed into it through narrowband imaging and all the rest of it. But Mount Wilson needs money. Okay, they need money to continue to add on to these programs. They need support to keep things operating up there. As I mentioned, they're mostly all volunteers. I know that Tom works his brains out coordinating all these things, and he's been very, very giving as far as entertaining all kinds of activities at Mount Wilson. And so, if you were a regular at Mount Wilson before COVID, you probably would have heard, symphonies playing up there in the museum, or it may be inside the dome. Incredible lectures that they have up there at Mount Wilson still. The visual viewing through the 60-inch, you will not forget it. I mean, it's just life-changing. Mount Wilson is still something that could very much affect your life and change your life, and it's worth supporting. And so I think on the website, is it mountwilson.edu? Is that the correct?
That's our website, yes.
Yes.
mtwilson.edu.
Yeah. So if you support Mount Wilson, you like what Mount Wilson's doing, you want to give Mount Wilson life to the next 100 or 200 years, you're going to want to give some sort of donation. It can be $10, $20, or more, but you'll find that the organization is very grateful and will treat you like a king, whether you've donated to them or not, because they want to inspire you. They want to show you what Mount Wilson was made of and what it is today and what it will be in the future. So, Tom, do you have any other things?
Well, there's nothing like being there in every sense. It's a great place to visit, to see these instruments very much as they were originally. I say, because we try to keep it visually the same. Most of the improvements are under the hood. You really can't see them, but they're there. And as far as using the telescopes, we do provide them when regular business is accomplished up there. Visually, these scopes are the experience. We'll call it the Mark I eyeball experience.
Yes,
it's so good. I mean, a camera just doesn't do it justice. No. I guess I'm spoiled as a visual astronomer. I like to see images, but there's nothing like your eye to see something really good. And I love that I have the opportunity to do that, and we make that available to people too. So if you have the opportunity, and we're back up in business, I invite you to please come up there and partake of any of our events that we have a visual program.
Yeah. Tim Thompson was also watching the show today, and he was chiming in. It was great to have him watch. Tim knows so much about these telescopes. He's often the telescope operator on the 60-inch, probably sometimes on the 100-inch as well. That guy knows so much about the history of Mount Wilson, and if you go and experience Mount Wilson, if you're lucky enough, you'll have him as your telescope operator or the person running the observatory for the night. And when we can, we're going back to Mount Wilson. We do the 60-inch star party. We have done a couple of them, and we plan to do more. So, Tom, thanks very much for coming on our show today. Make sure that you're watching at 3 p.m. Pacific Friday afternoon, and they'll take you into places that the secret places of Mount Wilson Observatory, and I'm praying for clear skies. So, thanks very much, Tom, and we'll see you.
Thank you, Scott.
See you very soon. Okay.
All right.
And take care.
Thank you, everyone.
Bye-bye.
And now, folks, it's time to say goodnight. We sincerely appreciate your patronage and hope we've succeeded in bringing you an enjoyable evening of entertainment. Please drive home carefully and come back again soon. Good night.